everyone, in this video we will discuss about the eudiometry, and eudiometry is simply known as gas analysis or gas stoichiometry. In the earlier videos we discussed about the stoichiometry. In the eudiometry we will discuss about the stoichiometry of gaseous reaction. So what actually we study in the eudiometry? So we will study that volume relationship amongst the gases, and second is composition of gaseous mixture. What is mean by this? When the two gases react as per the limiting reactant concept, which gas is left in the gaseous mixture and which is formed, and what gas can be absorbed by using a particular adsorbent. So what gas is formed and what gas which was in excess was present, it is studied in the composition of gaseous mixture. And the third one is determination of molecular formula of gases, and fourth one is molecular formula of gaseous hydrocarbon. So these are the four things that we will discuss in the eudiometry. So we have some assumptions. Related to the study of gaseous stoichiometry or eudiometry. The first one is each gas behaves ideally, so PV equal to nRT, which is ideal gas equation, is followed. And second one is, while dealing with the gaseous reaction, we will consider the volume of solid and liquid negligible. While dealing with the gaseous reaction, we will consider the volume of solid and liquid negligible. And third one is, ideally we will consider air contains nitrogen and oxygen only. One thing more, while dealing with the problems related to the eudiometry, first we will consider that in PV equal to nRT, which condition is given constant. So if P and T is constant, if pressure and volume is constant, we can say that if the identical condition of pressure and temperature is given, PV is equals to nRT and V is equals to nRT by P. So RT by P is constant, then we can say that V is directly proportional to N. Simply we can say that we can take the mole ratio or volume ratio as equal. Now if V and T, volume and temperature, is constant, we can say that P is equals to nR by V dot T. So RT by V is constant, so we can say that P is directly proportional to N. So for the gaseous reaction we can say that mole ratio, which is the stoichiometric ratio, or pressure ratio will be same. What is mean by this? Suppose we can write the gaseous reaction like combustion of methane, which is CH4G plus 2O2G. This will give CO2G plus 2H2OL. So what is mean by this? This is following the 1:2:1 ratio 2 stoichiometry. We can say that it's 1 mole of methane, 2 moles of oxygen, 1 mole of CO2 and 2 moles of H2. So when we will apply the identical condition of pressure and temperature, when P and T is taken as constant, we can say that the mole ratio and volume ratio will be same. So we can say that this will be the 1 volume, 2 volume and 1 volume. And if we'll write this 2 volume, it will be wrong because it is liquid. As I told you that in the gaseous reaction, the volume of liquid and solid is to be considered negligible. So what thing it is to be noted in the eudiometry? For example, if we are taking combustion of propane, it is to be noted that in combustion reaction, water will be formed in the form of liquid until or unless it is not mentioned it is in vapor. So definitely vapor will be converted into liquid. So there will be a decrease in volume. This is called volume contraction. So volume contraction is another term that will be used in eudiometry. And volume contraction means total initial volume, V total initial minus V total final. As in the combustion reaction, the volume contraction occurs because of conversion of H2OG or H2O vapor into liquid, right? There are other way due to which the volume contraction maybe occurs. There are certain absorbing reagent, we can say that absorbent, which can absorb a particular reactions. This kind of absorbent we will discuss later. Absorbent for gases, as we know that different gases can be absorbed at the different surfaces. So when we will put such kind of absorbent in the gaseous mixture, then definitely the volume may be contract or decrease due to these such absorbent. For example, for CO2 gas, we use KOH or NaOH as an absorbent. So let's understand the concept of eudiometry by taking the combustion of propane. What I'm saying, we are taking 50 ml of propane plus 300 ml of oxygen. 50 ml of propane and 300 ml of oxygen is allowed to react or allowed to undergo combustion. So what reaction we can write for this? C3H8G plus 5O2G. This will give CO2G and H2OL. So definitely 3 moles of CO2 will form in this and 4 moles of water will be formed in this. We want to analyze this gaseous reaction in which 50 ml of propane and 300 ml of oxygen is given. So at T equal to 0 means initially 50 ml of propane and 300 ml of oxygen is present. So these will react as per the LR, limiting reagent concept. So definitely in this reaction, limiting reagent is propane. We discussed about the limiting reagent concept in the simple stoichiometry. You can watch the video. So at T equal to T, this will become 0. Obviously we calculate, we do all stoichiometric calculation with respect to limiting reagent. So 1 mole of propane react with the 5 mole of oxygen. So 50 ml of propane will react with 250 ml of oxygen. So 300 minus 250, this will give 50 ml of oxygen in this mixture. And definitely because water is in liquid form, so we will not consider the volume of water. So with respect to propane, how much CO2 will be formed? Definitely it is following the 1 volume and 3 volume stoichiometry. So this will 150 ml of CO2 will be formed. So if it is asked that resulting mixture contains which gases and what is the volume of resulting gases, so definitely the total volume of gases in the resulting mixture will be equal to 50 plus 150, which will be equal to 200 ml. Now if further we will add the KOH in this gaseous mixture, and definitely what gas will be left in the resulting gaseous mixture? This is resulting gaseous mixture 1, and this is resulting gaseous mixture 2. We are adding KOH. We know that the KOH is absorbent for the CO2 gas. So definitely this KOH will absorb the entire CO2 present in this mixture. So only 50 ml of oxygen will be left in this gaseous mixture. Now, if it is required to calculate the volume contraction in the above question, what we can say, definitely the volume contraction, as I told you, that V total initial minus V total final, V total initial minus V total final. So obviously, why the volume contraction is taking place for this reaction? Because the H2O vapor is converted into liquid. So volume contraction will be equal to total initial volume, which will be 50 plus 300, which will be 350, and the final volume will be 200 ml, right? So 350 minus 200, this will give 150 ml. So 150 ml will be the volume contraction for this reaction. Now let's understand what absorbent we can use for different gases in the gaseous mixture, and how we can find the formula of hydrocarbon in the eudiometry. So if the gaseous mixture contains O3, ozone, then the turpentine oil is absorbent. For oxygen, it will be alkaline pyrogalol. For the NO, FeSO4 solution, and for NH3 it may be water. For H2O, CuSO4, CaCl2, and for CO it may be ammonical Cu2Cl2. So it is to be noted that these are the specific absorbent which is used for a particular gases. As I told you that if the gaseous mixture contains, suppose it is 200 ml gaseous mixture in which O2 and CO2 is present, and if we are adding the KOH in this, so 50 ml of oxygen is present in this and 150 ml of CO2 is present in this. So we can say that the KOH is absorbent for the CO2. So volume of CO2 will be equal to volume contraction because of KOH. So definitely it will be 150 ml. So then further resulting gaseous mixture contains only 50 ml of oxygen. In the same way, if the mixture contains, suppose 5 ml of ozone or 10 ml of oxygen, and now we are adding the turpentine oil in this, you know that the resulting gaseous mixture, the total initial mixture has the volume 15 ml, and we are adding the turpentine oil in this. So because of turpentine oil, the volume contraction occurs because it will absorb the O3. So the volume of 5 ml of ozone will be absorbed from this gaseous mixture, and the resulting gaseous mixture will contains only 10 ml of oxygen in this mixture. So these are the absorbent due to which a particular gas is absorbed, and definitely volume contraction occurs because of them. Now, one of the important application of the eudiometry, that we can determine the molecular formula of hydrocarbon using the stoichiometry. For this, all hydrocarbon, we can write this equation, which is CXHY X plus Y by 4 O2G and X CO2G and Y by 2 H2OL. To be noted that these are in gaseous phase. So we can write, if identical condition of PT is given or PT is constant, we can write that this will be 1 mole and this will be X plus Y by 4 mole. This will be X mole of CO2 and this will be Y by 2 moles H2O. Now we will write the under identical condition of pressure and temperature in the form of mole ratio. So definitely this will be 1 volume, this will be x plus y by 4 volume, this will be x volume, and as I told you that volume of liquid is considered to be negligible. So if Z volume of hydrocarbon is given, what I am saying, if Z volume of hydrocarbon is given, so we have already written the equation for the 1 volume of hydrocarbon. So for the Z volume, this will be multiplied by this. So for 1 volume, for Z volume, it will be Z volume, and this will be Z into x plus 5 by y by 4 volume. This will be xz volume. So we can write this equation for the Z volume of hydrocarbon, and we can find the formula of hydrocarbon. So in this section we learned that how we can apply the concept of eudiometry and what thing about the eudiometry must be noticed. In the next section, next video, we will solve problem based on eudiometry in the systematic way. Thank you very much.